Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Moving on, 7.2, the Ethernet MAC address. This is our physical address. A Ethernet MAC consists of 48 bits. It is normally expressed using 12 hexadecimal values, ranging between 00 and FF. We've already gone through hexadecimal, so you guys should be familiar with that. It's important to note that an Ethernet MAC address is broken up into two 6-byte groups. So the first 6 bytes are going to be part of the organizational unique identifier. Basically, IEEE will give you a OUI if you're following their standards. And once they give you that OUI, then you, the vendor, would then randomly generate the last 6 bytes. So in order to get that first 6 bytes, you have to follow IEEE standards when it comes to having an Ethernet MAC address. So again, when we're looking at this, a physical address is going to be a connection or an interface connection between some type of hardware and the network. Here we're looking at an Ethernet MAC address, so that means we'll have an Ethernet network interface card, a network card, and that gives us our Ethernet interface to the Ethernet network. So as long as you have an Ethernet interface, you should have a MAC address. So any device that has a Ethernet port will have some form of source MAC address. So how does a frame get forwarded? We already know that a frame looks at destination and source address information. So what ends up happening is, if I want to send something to another computer on the network, I will actually say who's out there. I will try to figure out who am I sending this to, and then I will forward the data accordingly. So essentially, I would have my source information. I would tell the switch I'm trying to connect to someone else out there, and hopefully the person responds. Well, the nice thing is, if I don't know the address of who I'm trying to send it to, I can send a broadcast. Basically, it goes to everyone, and the people that don't need to access it will just ignore it. This is called a broadcast, when it's sent to everyone. If I do know who my address is, that's going to be a unicast. So let's look at this a little bit more in depth. A unicast address is going to be a one-to-one, one device to another device. Normally, a source will always send it to a single address. Well, the nice thing is that single address can be different types of addresses. If I do not know where I'm trying to send something, I can do what's called a ARP request, a address resolution protocol request. And that is where I know the IP address of what I'm trying to access, but I don't know its physical layer. So I know it's layer 3, but not its layer 2. So I would send it to the switch. The switch would then allow me to modify my layer 2 address, and it will send it to everyone, looking to see who has that IP address. The person that has it, the machine that has it, would actually respond with, my MAC address is such and such. Again, the source MAC address will always be a unicast address. Unicast is one-to-one. A broadcast is one to everyone, to everything. And this is if you want to send something to everything. Well, the nice thing is, we have another specialty address that is called a multicast address. I want to send this to a select group of items that, like STP. I can send it to all devices that have STP. or all devices that have OSPF running. I can send that to a specific group, and only those people that have that resource running that is identified by our multicast address group would actually receive that frame. So unicast 1-to-1, broadcast 1 to everyone, multicast 1 to some, or 1 to a group. Again, we have a lab, which lab, again, we are doing in separate videos. Moving on, we have our MAC address table. So now that we understand MAC addresses, how does the switch use those MAC addresses? And what ends up happening is a switch, when it is powered on, has no known addresses. It has to learn these addresses, and this is typically taken from our source information. So when a device wants to communicate with someone else, it will actually take the source MAC address and it builds a table. This source goes to this port. This destination goes with that port, and so forth. The MAC address table is sometimes also referred to as a CAM, Content Addressable Memory Table, a CAM table. Essentially, it's a lookup table. That's really all it is. Again, the switch will do what's called learning. As a switch receives frames, it will actually learn the source and destination to figure out where the ports and what MAC addresses are attached to each port. By default, switches keep this data for about 5 minutes. And then if no other traffic flows, then the switch will actually delete the content. But as the switch receives more frames, it keeps resetting. If the source MAC address does exist in the table, but on a different port, the switch will treat each new piece of information as new entries. So a switch actually will learn MAC addresses based off of that information, and it's dynamic enough to update content as it receives it. So finding the destination MAC address, this is going to be forwarding. So if the destination MAC address is a unicast address, the switch will look for a match between the destination MAC address and its entry table. If it doesn't have it, it will treat it as a broadcast and it'll send it to everyone. Who is this or who is this name, or who's this device? And this will be called a unknown unicast frame. Basically, it's similar to a broadcast, except this is defined in a MAC address, not to send data to everything. Unknown unicast, broadcast, and multicast will actually be sent out every port except the port the request came in on. So here's a quick example. We have PCA connected to port 1. We have PCD connected to port 4. As PCA starts communicating, the switch will start learning that port 1 has this MAC address. As it starts delivering data to port 4, it will start learning, oh, port 4, this MAC address belongs. So it can start building its MAC address table based off of that content. Videos and labs, again, are done separate. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.